Okay, so for today's class, we're going to start to solve trig equations. So question 1a should start to look familiar to you. So all I'm asking you is cos of theta equals 1/2. So we answered these questions a number of lessons ago, right? But we looked at it as a trig ratio, and we could say what value of theta gives me that ratio. Well, that is the basis of our entire lesson for today. So that is also just a trig equation, right? Couple things to notice. You'll notice my instructions say solve for, and I give you between 0 and 2 pi. And I also ask for exact if possible. But so what I'm asking you is only for the angles that are located between 0 and 2 pi. So that requires no general statements. We need to be mindful of how many rotations and to give those answers. Okay, so let's go through question A. We should be able to answer this question quite quickly. We have cos is positive, where our adjacent side is positive. So I know cos is positive in quadrants 1 and 4. It's adjacent over hypotenuse. So I know that theta will be pi by 3 and 5 pi by 3. So I can use that special triangle to write my related acute angle, and I know that theta can either be pi by 3 or 5 pi by 3. Awesome. So what I'm hoping we notice in question 2 is now I've just written this as 2 cos theta minus 1 equals 0. I'm hoping we can quickly go to solve this equation by isolating for cos theta. And we notice that we get back to our cos theta equals 1/2, which at that point we would be solving the exact same trig equation, right? So we're trying to get down to that trig ratio. So again, my instructions for you there are let's isolate your ratio, which is what we just did in example B, and solve for the angle. So I'm going to give you a moment to write this out, isolate for your ratio, and then work to solve for your angle. So I'm going to give you a moment or two to do that now. Okay. So we have 2 sine theta equals -1. So sine theta is going to equal a -1/2. So we recognize a ratio of 1/2 gives us a special triangle. Sine is negative, where our opposite side is going to be negative, which means we have a terminal arm in quadrant 3 and quadrant 4. We can drop our height to create that triangle, and I know my opposite side over my hypotenuse. Use that triangle to find my related acute angle, and then from there I can state the values of theta. So I know theta will be 7 pi by 6, or I'm pi by 6 shy of a full rotation, so it would be 11 pi by 6. And again, if you recall, we were asked to solve between 0 and 2 pi, so only within that rotation that we see on our axes, or for one rotation on our unit circle. So again, isolate your ratio, solve for the angle. So I'm hoping what you'll notice in D and E is our equations are already simplified for us, but you'll notice we have our reciprocal functions. So a couple things that we can think about. Secant is 1 over cos, right? So if we think about secant is the reciprocal of cos, and we have secant theta is equal to a positive root 2. So if you want, we can think about where is cos positive. Cos is positive where our adjacent sides are positive, which means secant would also be positive in those quadrants. drop my triangles so that now I can drop my height so I now have triangles. And then I can think about secant is just the hypotenuse over the opposite side. So I'm going to show you more than one way that you can think about this. So maybe you go, it's the hypotenuse over the adjacent side. So I have my root 2. My adjacent side would have to be 1. And so we notice that we have our pi by 4 triangle. So our values of theta would be pi by 4 or 7 pi by 4. The other option, if you really are opposed to thinking about secant theta as hypotenuse over adjacent, is we just said that secant theta is equal to 1 over cos So another way I could have tackled that question was cos of theta equals 1 over root 2. Now obviously I would not need to see all of those steps. You could have gone directly, let me just get my coloring here. You could have gone just directly here to that's the same as cos of theta is equal to 1 over root 2. Either way, correct. I challenge you to try to think about secant as hypotenuse over adjacent. But again, either of those methods will get you to your correct answer. All right. So cosecant theta is reciprocal of sine. And we notice that our ratio here is negative. So let's think about where would sine be negative, where our opposite side is negative. So I want you to draw for yourself those terminal arms. So our opposite side is negative. What I would suggest is we think of cosecant theta of negative 3 or negative 1.5 as negative 3 halves. So all you'll notice that I've done is I've just changed that 1.5 to fraction form. The reason why I did that is so now I have integer values for my side lengths. Okay, so again, I can think of this as cosecant of theta is my hypotenuse over my opposite side, or keeping in mind that it is just the reciprocal, maybe you decided to change this into sine theta equals a negative 2/3. What I'm hoping you now also notice is one, my triangle is the same, right? Cosecant theta was hypotenuse over opposite, and sine is opposite over hypotenuse. So those should still provide me with the same triangle if I've written the reciprocal correctly. The next thing you'll notice is we do not have a special triangle for a side length of 2 and a hypotenuse of 3. So in this case, the easiest way to go about typing this into our calculator to find that related acute angle might be to keep it in terms of sine. So again, I want to remind you that sine was negative. So that's what told us what quadrants to put our terminal arms in. Now, I am going to use my related acute angle to find out what this angle actually is. So again, you'll recall our related acute angle, we use the positive ratio. So the negative told me the quadrants. Please be mindful that your calculator is in radians. Again, you were asked between 0 and 2 pi, which should tell you right away that it's in radians. And so now we have our, again, I don't need to see this step, your inverse sine on your calculator, 2 divided by 3. And we can go to 2 decimal places, so we should get 0.73. Now our last step, we've been asked to state, again, the values of theta that fit within 0 to 2 pi. So my first value of theta would be a pi rotation plus my related acute angle. So I would have pi plus my 0.73, or theta would give me a full rotation of 2 pi, and I would subtract that related acute angle. So 2 pi minus my 0.73. Oops. Should give me my second angle of approximately 5.55 radians. So, a couple things you'll notice. So to recap on this, in question D, we were given a ratio that produced a special triangle. So it was really quick to come up with my final answer by just thinking of my question as secant theta equaling root 2. So my hypotenuse over my opposite. I was very quickly able to get to that final values for theta. However, we notice in E, as soon as we had to start to use our calculator to find our related acute angle, it became a bit easier to think about that in terms of sine, just out of ease for typing that inverse sine into our calculator. So again, still very easy on either account to work with those reciprocal functions to solve our equations. So for example F, again, we want to isolate for our ratio, and then we want to find the values for theta. So I want to give you a minute or two to attempt this on your own from start to finish. So give it a go. Okay, so let's see how we did with this. So first, our goal is to isolate for our ratio. At which point we get cos theta equals a negative 1/3. At this point, a few things should be standing out to us. Adjacent over hypotenuse, we do not have a special triangle where my adjacent side is 1 and my hypotenuse is 3. So from there, I'm looking at it and going, my cos is negative. So that negative is telling me which quadrants. So I have cos is negative where its adjacent side is negative. So it will have terminal arms in quadrants 2 and quadrants 3. So the negative has told me that. I am then going to use my information about my related acute angle to find out what the value of alpha is. So I will look at cos of alpha equals a positive 1/3. Again, I know I want this to be in radians. And I get that alpha is a value of 1.23. So please be mindful that is the value of this angle here, of our related acute angle. So now to find out my actual values of theta, I am going to have a pi rotation, but I'm going to subtract that value of alpha, and then I'm going to have a pi rotation and I will add that value. So again, pi minus and pi plus. So again, please be mindful of what you are actually calculating for there. So again, just to kind of give you that bit of that background information as to why I suggest you use the positive ratio. One, our related acute angle deals with that positive ratio because it gives us our acute value, and we know that all of our trig ratios, sine, cos, and tan, are positive in the first quadrant. Okay, but what you'll notice is if you had just typed into your calculator cos of theta equals -1/3, so you did the inverse cos. Our calculators are programmed to, if it's possible to give us an angle in the first quadrant, we will always receive our the value of that first quadrant. If not, it will give us our first positive rotation. So if you typed into your calculator your inverse cos of a -1/3, you would have received an answer that theta is equal to 1.91, which you'll notice, yes, does give me my value of my first value of theta. However, that 1.91 is our principal angle here. So now you're going to have to try to use that information to interpret how do you get your second value of theta. Okay, and obviously there are a number of different ways that you can do that. But I just want to remind you that that's part of the reason why I use the positive ratio, is because it will calculate for me every single time my related acute angle, and then knowing where that related acute angle is in each of my triangles will allow me to really quickly find out that value of theta. So I want you to notice something huge is happening here in G, something that we can easily take into account, but something that is very impactful. So I'm hoping you'll notice this 2 is attached to our angle. It is a double angle, okay? So it's not outside, it's not in front of cos, it's not being multiplied by cos, it is inside of our angle. So we cannot just divide a 2 out of each side because that is part of our angle, okay? And you'll notice when we had to deal with our angles, in order to find the value of an angle, we had to take, so when we had something like this on the last question, in order to find that value of our angle, when we needed our calculators, we had to take the inverse of that cos. When we have our special triangles, that's how we can look to see what that angle is. Okay, so we cannot just divide out a 2 from every side. But what I want you to be, so let's think about what this means. So this means that we have a horizontal stretch by a factor of 1/2. So we're going to look at this in a couple of different ways. So I'm dealing with cos. My cos curve from 0 to 2 pi. Okay, we all know from our sketch of cos, if I had just given you the sketch of cos of 2 theta, and that's all I asked you to sketch, so y equals cos 2 theta, you would have said, okay, there's a horizontal stretch by a factor of 1/2, which means that our domain has been cut in half. So one cycle of cos would only take me a pi rotation. So to go from 0 to 2 pi, I would be able to fit in 2 cycles of cos. So that's something that I want you to think about there, okay? So we would have had, so what do we have here? We would have had that theta is at a y value of 1, at 0, pi, and 2 pi. Okay, so we'll notice that there's an extra amount there than we would have had between 0 and 2 pi. Okay, so what does that mean in terms of how can we think about this? So I'm going to extend this to you in another way as well, okay? We can think about, so I want you just to think about all of this as a cos theta. So you would calculate, when does cos theta equal 1? It would equal 1 at 0 and 2 pi is normally what we would have in that first rotation. Then what we would do is we could cut that in half because now we've dealt with our angle. And you'll notice I cut each of those in half and I would get 0 and pi. The problem becomes, as you notice from our picture, that we should also have, my final answer of theta should also have a 2 pi in it. So how can we take that into account? So what I want you to think about is originally cos of theta equaling 1, we would have given values between 0 and 2 pi. But as soon as we go to double that value of theta, I want to be thinking about, I've doubled theta, so what is happening between 0 and 4 pi? Because if I take what's happening between 0 and 4 pi and I cut all of that in half, I am going to fit into 0 and 2 pi. So again, to go back to this beginning here, so I could have said, for what values of theta is cos equal to 1? And because I know I'm going to be able to fit twice the amount into my answer, I write 0, 2 pi, and 4 pi. But that was my double angle, and I know the question asks me only to find theta, so I'm going to cut each of those values in half, and now you'll notice that theta is equal to 0, pi, and 2 pi. What does that look like on our terminal arm? For cos, I know my adjacent side is a 1 on my positive x-axis. So normally we would have 0. We would go through our rotation. We would have a 2 pi. But again, we know that we are going to be able to go through double. So if I go through another full rotation, that would get me to also my 4 pi. I go and cut each of those in half, and that is where I get to my final answer of 0, pi, and 2 pi. So with all of that said, what would you actually have to show me on this question? This and this. That is all the work I would need to see. That is the math behind it. And the biggest thing to be aware of is when we affect the angle, we are affecting the domain. So by that, you'll notice what I'm thinking about in terms of my domain, those values of theta. As soon as my angle is affected, those values of my domain is going to be affected. Okay, so let's continue to look at this. So first things, we're still going to isolate for our ratio. I can divide out this 2, right? Please be aware this 2 out in front, that's okay. It's a 2 times sign, so I can divide both sides by 2. Not a problem with that. Okay, oops. All right. The next thing I'm going to do is I am just going to think of all of this as sine of my angle equals 1/2. Okay, so I'm going to start to treat it the same. Sine is positive in quadrants 1 and quadrants 2. Can drop my height. I can use my special triangle to write out what my related acute angle is. And so I know those values, right? So I know what my related acute angle is. And so now I can start to think about a few things. So I can now keep in mind that normally I would be able to state what was between 0 and 2 pi. Because I have a double angle, which means horizontally stretched by a factor of 1/2, I actually can write out everything that was between 0 and 4 pi. That will all be included now in my final solution because I'm taking all of those values for theta, and I am cutting them in half. So again, so for what values of theta does that mean? So let's go all the way. So let's start with dealing with this domain here. So I have pi by 6. I have, it can equal, so 2 theta can equal pi by 6. Or we have 2 theta can equal 5 pi by 6. Or 2 theta, so you'll notice there's my first, that's 5 pi by 6, but I know I'm going to be able to go through a second rotation. So I'm going to come all the way around here. So I've hit 12 pi by 6, and I'm going to go up one more. So I have 13 pi by 6, or 2 theta. So again, I was at 12 pi by 6, and I can keep rotating, and I have to add 5 more pi by 6s. So I'm at 17 pi by 6. So you'll notice those are all of the angles that fit between 0 and 4 pi, because I have a double angle. But now, again, the question has asked us for what values of theta fit between 0 and 2 pi. So at this point, I have to take into account the double angle, because now I am dealing with my angle. So I can divide each of these in half. So so picture your graph, what was at pi by 6 just got cut in half, and now is at pi by 12. What was at 5 pi by 6 just got cut in half, so now it's at 5 pi by 12. What was at 13 pi by 6 just got cut in half, so now it's at 13 pi by 12. And lastly, what was at 17 pi by 6 just got cut in half, so it's at 17 pi by 12. So now all of those values fit between 0 and 2 pi. And again, I encourage you to think about that in terms of pi by 12s. A full rotation, so if we had 2 pi in terms of pi by 12ths, that would be the same as 24 pi by 12. So what you'll notice is we can fit in 4 values of theta will provide us with a ratio of 1/2 between 0 and 2 pi for this double angle. Okay, so in example I, still following our same steps that we want to isolate for our trig ratio. And what we notice here is, I'm hoping we notice instead, we have this angle that's theta divided by 2. So again, you're going to just treat this just like a theta for right now, so we can think about what we have. So we know that tan is negative in quadrants 2 and quadrants 4. We have our opposite over our adjacent. Awesome. And we notice that we have a special triangle here. So we've dealt with it the exact same way, but we know that we have this half angle now. So now we have to keep that in mind when we go to answer this question. So again, I'm going to state my values of theta. My values of theta would be 5 pi by 6, or theta divided by 2 would equal 11 pi by 6. But since we're dividing by 2, the opposite of dividing by 2 would be multiplying. I'm going to multiply both sides by 3, and I'm just going to reduce at the same time. And what you'll notice is we get theta is equal to 5 pi by 3 or theta is equal to 11 pi by 3. You should have a problem with that answer. And what you should have a problem about is you'll notice, I'm hoping you'll recall, I'm asking for values between 0 and 2 pi. And when you think about what 11 pi by 3 is, I'm hoping you'll recognize that 11 pi divided by 3 gives us a value that's greater than 2 pi. So this angle here is inadmissible. It does not fit for our given domain. So, a couple things. One, if we recognize that we had a half angle, which means we're really horizontally stretching everything by a factor of 2, that really means we're only fitting in half of what we used to fit into our domain. So again, we're affecting the angle, we're affecting the domain. Well, how does that affect it this time? Well, so if you just look at the top of the screen, you'll notice 0. Theta is between 0 and 2 pi. Well, if I have a half angle, what that really means is I'm only going to be able to fit in what happens between 0 and pi. Because when I go to multiply everything by 2, when I multiply it by 2, theta becomes our theta. When I multiply pi by 2, it becomes 2 pi. So I can only fit in a half rotation. So what happens between 0 and pi is all that is going to fit into my domain when I multiply those values by 2. So if you had recognized that, and we went, if I'm taking everything and I'm multiplying it by 2, and this is pi, then only what fits between 0 and pi when I multiply that by 2, those angles by 2, pi times 2 is taking me to 2 pi. So none of what's happening in quadrants 3 and 4 will fit within 0 to 2 pi. So if you had recognized that at the beginning of the question, I don't need to see this work here. Obviously, if you want to show it and that's how you work through your process, perfectly correct. But again, you do not need to show that to me. But this is really important because for tan, you'll notice only one of our angles fits within 0 to pi, so that when we multiply that angle by 2, because we've horizontally stretched it by a factor of 2, that's what's going to fit between 0 to 2 pi. I'm hoping you'll notice that that can change depending on the ratios that we've been given. If this question had been sine of theta equals a positive 1 over root 3, we know sine is positive in quadrants 1 and 2. So we still would have had 2 answers for theta once this was horizontally stretched by a factor of 2. We still, in our half angle, we still fit in 2 of our terminal arms. Okay, what if that had been sine of theta equals a negative 1 over root 3? Well, sine is negative where its opposite side is negative. And what we notice is if we had been, these should have been sine theta by 2's. If that was the case, you'll notice between 0 and pi, we have no values of theta that would have fit within that domain. Okay, so being mindful of what does theta divided by 2, that half angle, mean? Again, we can think of it, it's a half angle. So we've horizontally stretched our graph by a factor of 2. So what we fit into 0 and 2 pi, we only fit half of what we used to fit in. Okay, so we used to fit in half, but we are horizontally stretching everything by a factor of 2, and which makes sense as to why we can only fit in half of what we used to fit into our rotation. Okay, so let's look at J. So first I'm going to isolate for my ratio. I know sine is positive where its opposite side is positive. My related acute angle. And so then I know I'm going to just think of this as all one angle together for right now. So sine of what value will give me 1/2. And so I know that it's going to be theta divided by 3. And that's going to give me a pi by 6. Or it's going to give me a 5 pi by 6. And so a couple of things. So let's say you just went with it. You go, okay, I know it's a theta divided by 3. So I'm going to horizontally stretch everything by a factor of 1/3. So it's going to get wider. So I know I don't need more examples. But I'm not quite sure if that 5 pi by 6 is going to fit in or not. So maybe you just write those ones out. And then you go, okay, right now I'm giving an answer for theta divided by 3. Right? Instead of just theta. So I have to multiply everything by 3. So I'll reduce at the same time. And I realize, oh, yep, Kate 5 pi by 2 isn't going to fit in that 0 to 2 pi rotation. So I'm going to state that that is inadmissible. So I knew because theta was being divided by 3 that I wasn't going to have to include more angles because I wasn't cutting them in half. Rather, I was multiplying them by a factor of 3. So I was making those values of theta larger. Okay, so maybe that's one way you went about answering it. Or maybe you looked at it and said, okay, I know I'm normally starting with, I need to tell what values of theta is between 0 and 2 pi. So what's happening with this one is instead, so what I'm going to have here is a 2 pi by 3. So only the angles that fit within 0 and 2 pi by 3 on my original unit circle will actually fit into my final values of theta. Okay, so maybe you looked at it that way and you said, okay, I know I only need for my original unit circle values between 0 and 2 pi by 3. And I know that this 5 pi by 6 is not going to fit in between 0 and 2 pi by 3, so I do not need to include it. And as a result, you went straight to your answer of only what is shown there in black and not included in the green. Okay? All perfectly great ways of going about answering that solution. Okay? So just, again, I'm just trying to show you that full picture, so hopefully that you can understand it in a way that works for you. Let's look at K. So again, first things first, isolate. Okay. Cos of 2 theta. So I know cos of theta, cos is negative where our adjacent side is negative. And drop my heights to get those special triangles. Adjacent over hypotenuse. So I'm dealing with pi by 3 angles. Again, this comes as a unit right now. So I have 2 theta is equal to, I am going to have a 2 pi by 3 or a, and helps if, let's fix that. My apologies, everyone. I didn't put a square root underneath. Sorry. Yeah, my apologies. That should be a pi by 4. Let's fix that. Square root should not magically disappear. That is, in fact, a pi by 4. I just got a little ahead of myself. All right, we're back. So we have a negative 1 over root 2. So I know that is going to be a 3 pi by 4 or a 5 pi by 4. But since I have a double angle, I am going to go through a double rotation. So now, again, I'm hoping you'll notice I'm just adding 2 pi. And since 2 pi can be written as 8 pi by 4, really I'm just adding 8 pi by 4 to each of these. So I'm going to have or 11 pi by 4 or 13 pi by 4. At which point, again, we know 11 pi by 4 and 13 pi by 4 are outside of our current domain of what we want of 0 to 2 pi, but we still have to cut all of those values for our angle in half. So we will have a 3 pi by 8, 5 pi by 8, 11 pi by 8, or 13 pi by 8, which we notice all of them are less than 2 pi. So that's one way we could go about answering this question. Again, some extra information if you were wanting to think of it this way. Normally, or the question's asking for our domain between 0 and 2 pi. We have a double angle, which means we are going to take everything between 0 and 4 pi, because when we go to deal with that double angle and horizontally stretch everything by a factor of a half, we will now, those values for theta will fit into our domain. So a couple of different ways, again, that you can think about that to answer these questions. So you do have practice questions posted that you can work on for these.